In 2009, NASA launched a spacecraft with one of the biggest missions in human history.
Its goal was not to land on Mars, not to visit Saturn, not to take beautiful photos of galaxies. Its mission was much quieter, but much deeper. It was sent to answer a question that has followed humanity for thousands of years. Are there other worlds like Earth? And maybe, are we alone? The spacecraft was called Kepler, and Kepler changed everything. Before Kepler, scientists had discovered some planets outside our solar system, but we still did not know how common they were. Were planets rare? Was Earth special? Was our solar system unusual? Or was the galaxy filled with hidden worlds orbiting distant stars? Kepler was designed to find out, but it did something surprising. It did not search by taking direct pictures of planets. Most exoplanets are far too small, far too dim, and far too close to the glare of their stars to be seen directly. Instead, Kepler searched for shadows, tiny shadows. When a planet passes in front of its star from our point of view, it blocks a small amount of starlight. That tiny drop in brightness is called a transit. For a giant planet, the dip may be easier to detect, but for an Earth-sized planet, the change can be incredibly small. Imagine trying to notice a mosquito crossing in front of a stadium light from miles away. That is the kind of precision Kepler needed, and somehow it worked. Kepler stared at one small region of the sky, near the constellations Cygnus and Lyra. To the naked eye, that patch looks ordinary, just another part of the night sky. But Kepler watched it with extreme patience. Over 150,000 stars, again and again, hour after hour, day after day, year after year. It was looking for a repeated pattern. A star shines normally, then it dims slightly, then it brightens again. Later, the same dip happens again and again. That repeating signal tells scientists a planet may be orbiting that star. The timing reveals the planet's orbital period. The depth of the dip reveals the planet's size, and the star's properties help estimate whether that planet could be rocky, gaseous, frozen, or burning hot. Kepler was not just discovering dots in space. It was measuring alien solar systems by reading starlight. And then the discoveries began. Kepler found giant planets orbiting extremely close to their stars, worlds where a year lasts only a few days, worlds so hot that metals could vaporize. It found planets larger than Earth but smaller than Neptune, a type of planet strangely missing from our own solar system. Scientists call many of them super-Earths or mini-Neptunes, and this was shocking. Because our solar system has small rocky planets like Earth and Mars, and giant planets like Jupiter and Saturn. But Kepler revealed that the most common types of planets in the galaxy may be planets we do not even have here. That means our solar system may not be the standard model. It may be just one version among countless possibilities. Then came the discoveries that captured the world's imagination. Earth-sized planets, rocky candidates, planets orbiting in the habitable zone. The habitable zone is the region around a star where temperatures could allow liquid water to exist on a planet's surface. Not too close, not too far, not guaranteed to be alive, not guaranteed to be Earth-like, but possible. And in space science, possible is powerful. One of Kepler's most famous discoveries was Kepler 186f. It was the first validated Earth-sized planet found in the habitable zone of another star. It orbits a red dwarf star, much cooler and smaller than our Sun. Its orbit is closer than Earth's orbit around the Sun, but because its star is dimmer, the planet may still receive an amount of energy that puts it in the habitable zone. No one knows if Kepler 186f has oceans. No one knows if it has an atmosphere. No one knows if it has life. But its discovery proved that Earth-sized worlds in habitable zones are real. Then there was Kepler 452b, a planet sometimes nicknamed Earth's cousin. It orbits a star more similar to our Sun. Its year is longer than Earth's, and its star system is much older than ours. That alone raised fascinating questions. If a planet has existed in a habitable zone for billions of years longer than Earth, could life have had more time to develop? Could civilizations rise and disappear before we ever knew they existed? Or is it just a silent world, orbiting quietly in the dark? Kepler could not answer those questions directly, but it gave us the targets, the evidence, the statistics. And those statistics changed astronomy forever. Because Kepler showed that planets are not rare, they are common, extremely common. In fact, based on Kepler data, scientists estimate that planets may outnumber stars in the Milky Way. Think about that. Every star you see in the night sky may have planets, and many stars you cannot see may have planets too. There may be billions of rocky worlds in our galaxy, billions of chances for chemistry, billions of chances for oceans, billions of chances for life.
Before Kepler, we wondered if Earth was a cosmic miracle. After Kepler, the question changed. If planets are everywhere, where is everybody?
This is where the mystery becomes even deeper. Kepler gave us a galaxy packed with planets, but it did not find aliens. It did not detect cities. It did not hear signals. It only showed us that the stage is enormous. The actors may be out there, but we have not found them yet. That tension is what makes Kepler so important. It made the universe feel more alive and more mysterious at the same time. Kepler also showed us how strange alien solar systems can be. Some systems are packed tightly with planets, orbiting closer than Mercury orbits the Sun. Some planets orbit two stars, like a real-life version of the fictional world Tatooine. Some planets are locked in orbital rhythms, where their years form mathematical patterns. Some worlds may be covered in lava. Some may be ocean planets. Some may be gas-rich mini-Neptunes with crushing atmospheres. Some may be rocky planets with no air at all. The galaxy is not just filled with copies of Earth. It is filled with variety beyond imagination. But Kepler's mission was not easy. In 2013, part of the spacecraft's pointing system failed. Kepler needed reaction wheels to aim precisely at its target stars. When enough of those wheels stopped working, the original mission could no longer continue as planned. For many missions, that would have been the end. But NASA engineers found a creative solution. They used sunlight itself as a balancing force. By carefully positioning the spacecraft, they allowed pressure from the sun's light to help stabilize it. This new mission became known as K2, and Kepler kept discovering, even after damage, even after its original design was compromised. It continued scanning different regions of the sky and finding more planets, star clusters, supernovae, and cosmic events. That is one reason Kepler became legendary. It was not just a successful telescope, it was a survivor. But eventually, after nearly a decade in space, Kepler ran out of fuel. Without fuel, it could no longer point itself accurately or send data back to Earth properly. In 2018, NASA officially retired the spacecraft. Kepler was left in a safe orbit around the Sun, silent, alone. But its data is still alive. Scientists continue studying Kepler's observations. New planets can still be confirmed from old data. New techniques can reveal signals that were missed before. In a way, Kepler is still discovering worlds even after its mission ended, and its legacy continues through newer missions. NASA's TESS mission now scans nearly the entire sky, looking for planets around bright, nearby stars. Kepler looked deep into one patch of space. TESS looks wide across the sky. Together, they changed the search for planets from a question of whether they exist to a question of which ones we should study next. And now, the James Webb Space Telescope is taking the next step. Kepler could detect the shadow of a planet. Webb can study the light passing through some exoplanet atmospheres. That light can carry chemical fingerprints, water vapor, carbon dioxide, methane. Maybe one day, oxygen. Maybe one day, a combination of gases that suggests biology. Not proof by itself, but a clue. A sign that somewhere out there, a planet may not be dead. This is the future Kepler helped build. Find the planets, study their atmospheres, search for biosignatures, compare worlds, understand how planets form, and eventually, maybe identify a world where life exists beyond Earth. But there is something even more profound about Kepler. It changed our emotional relationship with the universe. For most of human history, the night sky was a mystery of lights, beautiful, distant, unreachable. Then science revealed those lights were stars. Then we learned our sun was one star among billions. Then we learned our galaxy was one galaxy among billions. And then Kepler showed us that around those stars are worlds, not empty points of light, systems, planets, possibilities. A sky full of suns became a sky full of places. That is a massive shift. Because when you look up now, you are not just seeing stars. You are seeing potential homes, potential oceans, potential skies, potential histories. Maybe planets with storms larger than continents. Maybe planets with endless deserts. Maybe frozen moons with underground seas. Maybe rocky worlds where sunrise happens under a red star. Maybe worlds where two suns rise at once. Maybe worlds where life never began. Maybe worlds where life is simple, microbial, hidden beneath ice. Maybe worlds where intelligence appeared, looked up, and asked the same question we ask. Are we alone? Kepler did not answer that final question, but it made the question impossible to ignore, because now we know the galaxy has the real estate. The ingredients may be widespread. Water exists in many places. Organic molecules exist in space. Planets are everywhere. So the search is no longer fantasy. It is science. And that may be Kepler's greatest achievement. It transformed the search for other worlds from speculation into statistics, from imagination into data, from science fiction into a measurable field of astronomy. Kepler told us that Earth is not alone as a planet. The deeper question is whether Earth is alone as a living world, and that question is still open. But every discovery brings us closer. Every new telescope sharpens the view. Every new planet adds another possibility. One day, scientists may detect an atmosphere around a small rocky planet and find something unusual, a chemical imbalance, a strange combination of gases, a signal that cannot be easily explained by geology alone. And on that day, the story that Kepler began may reach its greatest chapter. Not just the discovery of another planet, but the first real clue that life exists somewhere else. Until then, Kepler remains one of NASA's most important missions, a telescope that stared into darkness and found worlds, a spacecraft that looked for shadows and revealed billions of possibilities. A mission that proved the galaxy is not empty. It is crowded with planets, crowded with mysteries, crowded with chances. And maybe, somewhere out there, around a quiet star we have already measured, there is a planet with clouds, oceans, and a sky. A planet where the light of its star falls on mountains and seas. A planet where something living moves beneath that light. A planet waiting to be found. Kepler is silent now, but because of what it saw, the universe will never look empty again. This is infinite science, and the search for another Earth has only just begun.